Hello, algebras, and welcome to Chapter 11, Lesson 3, Day 2 notes. So we're going to take graphing our quadratic functions using our graphing calculator, using the x equals negative b over 2a, the axis of symmetry formula algebraically to help us now kind of look at the functions we were looking at before and maybe some functions in something other than standard form. And so standard form isn't the only way we can represent our quadratic functions and graph them. So let's kind of take a little peek at what we've got going on here and how this different form of looking at our functions might give us some insight as to what the zeros of our function are. Okay, so I'm just going to start off by graphing the quadratic function f of x equals x squared minus 6x plus 8. And I will just continue to use my graphing calculator to do so. So let me just pull this guy a little bit bigger and plug in x squared minus 6x plus 8. So this is the function that I'm going to graph, standard form from right here. And if I press graph, I will see it. I can already figure in my head what the axis of symmetry is going to be. X equals 3, right? And if I look now, 1, 2, 3, there it is. I can scooch this a little bit and the picture will still be the same size. There we go. Okay, I can see the y-intercept right here, 0, 8, and that's because this number 8 is the last number right there at the end of the function if your x value is all 0, right? We can see the roots right here and here. So 2 and 4 being my roots. And of course, my vertex is on my axis of symmetry, so it looks like it's going to be 3, negative 1. But we can verify all of that with our table. So second and graph gets us our table of points. Now, it's pretty obvious that I am not graphing negative 8, 120. But if I start to look down here, I get some more reasonable things to graph, like this y-intercept 0, 8. And so let's arrow down a bit and look at a reasonable interval to graph our functions. So 0, 8 to 6, 8 will actually fit on my graph. So what I'll do here is I'll put that table, since I'm pulling this from my graphing calculator, I'll put that table right over here. Okay, and let's see, we said 0, 8, which is of course my y-intercept. And then we said 1, 3, and then we said 2, 0, and then 3, 1, oh, negative 1, that's right, because we're below, yep. And then back again, 4, 0, oh, that's right. This was my axis of symmetry, x equals 3, and my turning point, 3, negative 1. And then 4, 0, there's a root. 2, 0 was a root. And then we've got 5, 3, and 6, 8. And so let's get these on the graph. 0, 8, 1, 3, 2, 0, and then down here, 3, negative 1, back up to 4, 0, and back up to 6, 8 at the very end. Connect. Put arrows on the last points that fit, which do include this y-intercept right here, right? We don't want to try and pull our pull our quadratic function up further. We don't want to guess where that next point, that negative 115 should be, because if we guess wrong and we connect wrong, then our parabola is wrong, and we don't want to do that. So we just stop at that last point that actually fits, and we put our arrows there and label f of x equals x squared minus 6x plus 8. And what I'll do now is I will just label all the stuff that we labeled in day 1. So right now I'm putting in my dashed line for my axis of symmetry. Axis of symmetry equation is x equals 3. My vertex, of course, is right on the axis of symmetry, and that's 3, negative 1. My roots are where I touch across the x-axis, and that would be 4, 0, and 2, 0. And my y-intercept right here is 0, 8, the one where my x value is 8. Sorry, my x value is 0. There we go, the one where my x value is 0. And the matching y value is actually just the number at the very end when we're in standard form, right? The C term. when we're in standard form. I think that's all the fun stuff that I have been labeling. So now let's answer the questions. What are the zeros of this function? Okay, well, two ways I can represent the zeros. Just going to press graph again because we've got our table over there so you can see the graph on the graphing calculator. Two ways we can represent our zeros. Put them in French curly braces as the two x values of our zeros, like we did when we were solving for x in chapter 8 and chapter 10. Or we can say 2, 0 and 4, 0 because those are the points for the roots. Now, what we're going to do is we're going to factor this trinomial that's been given to us, x squared minus 6x plus 8. Well, that sounds kind of familiar. We're going to factor that into two binomials. Well, let's see. That's a trinomial. So what are the factors of 8 that are going to add to give me negative 6 in the middle? That sounds like x minus 2 and x minus 4, right? Because negative 2 plus negative 4 is negative 6 for the middle, and negative 2 times negative 4 gives me the positive 8 at the end. So what if I took those and I plugged those into my graphing calculator as the function? What if I did that? Look down here. That's what I'm going to plug into my graphing calculator. So I'm going to press y equals. I'm going to arrow down to y2, and I'm going to plug this in, which, by the way, of course, I have my binomials ordered differently, but we know that multiplication is commutative, so it doesn't matter the order in which I multiply the binomials together. What matters is what's inside the binomials, just like this. Okay, making sure that those are the right signs and the right numbers inside the binomials, like I have here, so that doesn't matter, that particular part. And then press graph to see it. So remember, our old one was the blue and our new one is the red. What happened? When I pressed graph to see it, that red completely covered the blue that was already there. When I press second in graph, I look at these points and they are identical. So what happened here? This is exactly the same function, and it's just represented differently. I took the polynomial part and I factored it, and I used those factors to represent it in function form. Okay, what were the zeros of this function? They were 2 and 4. If I was solving this, let's say I took this and I set this equal to 0. So I replaced f of x with 0 and I solved for the zeros. I get x equals 2 and x equals 4. So I got my zeros from that solving. Essentially, what we're saying is, A, we can represent our function equations in a different form, and B, we can use that factorability of a function equation to determine the roots. Or if we know the roots, we can go backwards and create the function equation. That's the bigger piece of today. If I know the roots, I can go backwards and I can create the function equation. And that's what we're going to look at. So I'm not going to regraph the exact same parabola I already had graphed, and we already see that that's exactly the same. I wanted to make that connection. I did this solving that's down here. How are these zeros related? They're the same because these functions are the same. Okay. So what we're going to do is we're going to use that information to help us build function equations. In example number 1, given roots of positive 5 and negative 7, build a quadratic function that would have these same roots. So if I know that my x value is 5 and negative 7, and I want to build a quadratic function, let's t-chart backwards. what kind of equation does this come from? So get one side equal to 0. So subtract 5 over, you get x minus 5 equals 0. Okay, add 7 over, you get x plus 7 equals 0. What two binomials would this have come from? Well, x minus 5 and x plus 7 equals 0. There was the quadratic function. I just need to replace 0 with f of x or g of x or h of x. And because I haven't used it yet today, I'm going to choose g of x. There we go. This quadratic function will have a 0 at 5 and negative 7. Let's double check. Go back to y equals. Let's plug it in. Just going to y1. I cleared out what I already had in there. X minus 5 and x plus 7 should have should have roots at 5 and negative 7, meaning it touches and crosses the x-axis at 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, negative 7. There you go. We built the right equation. Okay. You could FOIL that out if you wanted to. So if I wanted to FOIL this out, my equivalent equation would be x squared plus 2x minus 35 from FOILing. And again, to check that, if I go to y equals, and I just put that in right here, I can check to make sure to verify that I have FOILed correctly, and these end up being exactly the same function when graphed. So the red should cover the blue completely. And there we have it. Let's look at another way this question might be asked. Okay, let's look at another way this question might be asked. Using the graph, create a quadratic function that have these same roots. Okay, what are the roots? Well, the roots are negative 4 and 0, right? So let's, again, take those values for x and go backwards. So add 4 over, this becomes x plus 4 equals 0, to get 1 equal to 0, right? Well, here, this is already equal to 0, so this would really just be my value, right? So this would just be an x, and this over here would be an x plus 4. So those are what I'm multiplying together and set equal to 0, right? It said create a function, quadratic function. So I do have to put an f of x or a g of x, or I'm going to use an h of x. And just out of habit, I'm going to put the x first, then the x plus 4. Okay. Now let's plug that into y equals on my graphing calculator, see how that goes for me. Let's see. X times x plus 4. And press graph to see it. Oh, look at that. Root at 0, root at wait. What did I do wrong? What didn't I consider had to happen here? I've got the roots in the right spot. Do I have the same quadratic function? Did it say I needed the same quadratic function? No, it said I needed a quadratic function with the same root. So I'm technically right. But what really should I have had happen? To be exactly the same function, this would need to be negative. So another answer for this, an alternative answer, I'll use f of x since this is a different function, would be negative x times x plus 4. Right? To get my same roots. Well, that's really more what I want. Let's just do it that way. Let's do negative of x plus 4. And I'll show you why. You really just want that whole thing to be negative in order to go that direction and still have that same roots. So either of those actually works because it didn't say I wanted exactly the same function equation. Isn't that neat? We just wanted to have those same roots. Okay. Other places that applies. What if I now have 1, 2, 3 binomials. How many roots do I have? 3 roots. Can you predict what those roots are? Think about it. On example 3, can you predict what those roots are? Look at the binomials I've been using, and then look at the roots I've had, and can you predict those? Right? Let's prove it. Again, go to the graphing calculator, go to y equals. Let's clear out what we already had in there. And in y1, let's put the binomials we were given, x minus 8, x plus 3, and x minus 5. And let's press graph and see what it looks like. Oh, okay, so it's like kind of all over the place, right? This is actually cubic, so it does the like vertical snake. But look at where my roots are. -3, +5, +8. Opposite signs of what's inside the binomial ends up being my roots. Okay. Now, what could the equation of this function be? Look at its roots, right? Look at its roots. So we've got a root at -1. We've got a root at +2. We've got a root at +3. So if we're building these binomials, we need x plus 1, opposite sign, x minus 2, opposite sign, x minus 3, opposite sign. And where do we see something close to this? Right? Because we need that to be that need to be positive. So we bring out a -1, bring out a +2, bring out a +3. That's it. That's your answer. Oops, I'm sorry. That's it. That's how we do it. And you can double check that by then going to the graphing calculator, get rid of what you already got in there, and then x plus 1 in the binomial, and x minus 2 in the binomial, and x minus 3 in the binomial. And let's press graph to see. Same picture. So it's kind of neat. Now we can take that information we know about where our quadratic or cubic touches and crosses the x-axis as the roots, as the zeros, and we can go back and build the equation with that. What a great thing that we can go back and forth, and those connections to the equation are so important. And it's like you can use all this back and forth all the time to check yourself and make sure you're doing things correctly. These built-in checks. Plus you have the graphing calculator, which is awesome. What a tool to make sure you're doing things correctly. Look, give this a try. These are former Regents questions, which is why we build to where we're at, having already solved for roots by factoring, right? So we've already established the connection between the roots of a quadratic function and solving a quadratic equation with that same equation piece. So we've established that connection, and now we're going to use that connection to our advantage. Let me know if you need anything, but please practice this with the homework. Practice using the graphing calculator to check yourself. I will see you very soon for application of all these fun quadratic functions. This has been your Chapter 11, Lesson 3, Day 2 notes. I will be seeing you guys very soon for Lesson 4.